Well, hey folks, thanks for joining the meetup today. I've got a great presentation to share with you, and there's lots to cover. So without further ado, let's jump into workflows for Elixir Nerves. So first, a quick introduction to me. This photo was taken the only time I've ever worn a tuxedo. That's my Twitter handle below it, in case you want to follow me on Twitter. I live in the mountains of North Carolina in Marshall, and I enjoy whitewater paddling. These are a couple of the canoes I have. And I live near the Appalachian Trail and enjoy getting outside. It's a good place to get outside here. I'm most happy working in ClojureScript or Elixir, and I use NixOS with Emacs for my workstation. And I'm a worker owner at Full Steam Labs, where I build digital tools for environmental sustainability. So Nerves for the win. I'm telling you, now is the best time to get started with Nerves. You might be saying, what about the chip shortage? Why now? Well, reasons. Some of those reasons include an improved developer experience and on-ramps, better documentation than ever before, more target device support with the BeagleBone Green Gateway and the Mango Pi MQ Pro on the way, an acceleration in open source contributions, including most recently the Bright Pi, the Inky Impression, and the Unicorn Hat. And the Nerves core team is growing, which is a good sign. Congrats, Masatoshi. So this talk, we're going to explore Nerves in various contexts. And what do workflows include? Well, for us, it's connecting to, interfacing with, and loading firmware to Nerves targets. And for a little fun, this talk is going to have a retro electronics theme. So here's a few just to get us started. We've got a Polaroid Sun 660, which was introduced in 1981 with sonar autofocus. The classic Commodore 64, best-selling computer in history, 17 million units sold between 1982 and 1993. And a Panasonic KX P1150, one of the early dot matrix printers. So what's in store with this talk? Well, we're going to talk about these workflows. I'm not going to list them off to you here, but I will say that this presentation is jam-packed with links and extras, including references and history about each of the devices that are featured. So make sure to check out the public version of the slides after the show. And with that, we're going to turn it up to 11 with PDP-11, a 16-bit microcomputer introduced back in 1970 that served as the inspiration for the early Intel x86 processors. So let's get started with SD cards. Everything starts here. This is the most primitive workflow for Nerves. Typically with Nerves, you'll use mix-burn or mix-firmware.burn. But there's other options. FWUp is used under the hood with mix-burn, and you can use that directly if you really want to. Or if you've got your firmware image ready to go, you could use DD or a GUI tool like Balena Etcher. You'll probably want to pick up an SD card adapter like one of these or an SD card reader, and make sure to choose the right SD card. It's really important to choose a good brand like SanDisk, Samsung, or PNY. They've all got pretty good records. So the use cases for SD cards. These include early development, of course, because you can't really get Nerves running without the SD card. If you're creating a custom Nerves system, you're also going to want to be using an SD card quite a bit. And the same thing is true if you're working on unsupported development boards or hardware. And if you're trying to do any device provisioning sequences for the first boot of the device, you really want to have fresh firmware burned onto that SD card so you can get a test of what's going on for that very first boot. So some of the benefits of working with an SD card is it ensures fresh firmware is on your device. And if you've got a large firmware image, sometimes it's faster to do an SD card burn than wait for it to go over the wire with Wi-Fi. Some of the drawbacks, though, are it can be cumbersome. And if you do it a lot, you can wear out your SD card pretty quickly. And if you're in the middle of a workflow, having to pop that SD card in and out of the adapter and into the device can really interrupt your flow. So before we move on, I want to mention a couple of these devices here. We've got an Apple 5.25-inch external floppy disk reader. It was introduced back in 1986. Some of you might remember this. And there's, just for an example, a 5.25-inch floppy next to it. So moving on to serial cables. Serial cables allow you to open a direct console connection to the Nerves target through a terminal emulator-like screen. And when you're looking for these, you probably want to look for an FTDI cable. FTDI Chip is the company that makes the most of these cables. And there's a 6-pin, a 4-pin, and a 3-pin variant of the cable. The 3 pins that you really need are transmission, receive, and ground. And if you're looking for one of these, make sure that you get a 3.3 volt cable, because there's a 5 volt variant out there too that is probably a little bit too much for your Nerves projects. So, oh, and just going back real quick, that's the 6-pin variant there in that image. In the image here, this is the 3-pin variant. So use cases for serial cables are plentiful. You can use them in early development. It's great for getting started. And if you're doing any firmware debugging and you need to know what's going on at the very start of the boot, it's great. And hardware debugging in general, it's the right tool to grab. I would say serial cable is one of my favorite ways to work with Nerves. So some of the benefits of working with Nerves are you get to see console output immediately, which is great. And there's no networking, no configuration that you need to do. You just plug it in and plug it into your USB port on your device, on your computer, and get going. You do have to be careful though, because the TX and RX cables or pins can be confusing. Some of the labels on your target devices might be opposite of what you expect. And it's kind of like USB. If you plug it in one way and it doesn't work, just flip it over and it'll work the other way. Same thing goes for TX and RX, just flip them around. I am listing as one of the drawbacks here, it includes wires, because we've got so many other options with Nerves that don't include wires. It's kind of frustrating sometimes to have to shuffle with wires. And if you've got a bunch of cables, you might have a rat's nest of cables in your closet or something. And I know this isn't always the case, but sometimes when you're using screen or other terminal emulators with a serial cable, you'll have a bit of an impaired console that might make it difficult to search or scroll or do things that you're used to in the terminal. And of course, if you're traveling or you don't have one yet, they just might not be available. So I would say if you don't have one, go out and get one. This is a great tool for working with Nerves. And before we move on, I just want to mention these images here. We've got a serial RS-232 extension cable and a Digital Equipment Corporation VT100 that was introduced back in 1978. And most terminal emulators today are still based on the VT100. So moving on to HDMI. So some Nerves devices include HDMI or HDMI mini ports that you can connect directly to external displays. This is pretty awesome. It allows you to get up and running really quickly. So use cases, again, like serial cable, early development. If you don't have a serial cable, but you do have HDMI, it's a good thing to reach for. Hardware debugging, of course, is also a great use case. If, again, you don't have the serial cable, HDMI is going to get you pretty far. Kiosks are also an interesting way to use HDMI. If you've got a screen that you want to connect to and a Raspberry Pi that supports HDMI, you can build yourself a case and hide everything away and just use a cable to connect things. So that bullet point there is a link to a Nerves starter repository that is set up for building kiosks. So check that out when you look at the slides later. Some of the benefits of working with HDMI, you see console output pretty early. It's not as early as serial because some things need to boot up before HDMI output actually goes out. But there's no networking and really no configuration involved. You just plug it in and go. But again, wires, not always the best thing. And if you don't have one, then you're out of luck. I would say though, if you're trying to get an HDMI cable, make sure you get the right one. There's a few different types of HDMI out there, really more than a few. And you need to be careful to pick the right one. And just as a warning, not all Nerve system images enable HDMI by default. So check on that before you get frustrated. Moving on to USB. USB is actually the suggested path of least resistance for connecting to your Nerves target. It's in the official Getting Started guide, and it's a pretty easy way to go if you're just getting started. And I should mention this image. This is a Raspberry Pi 4 with USB-C. And as we move on here, this is a Raspberry Pi Zero 2 with micro USB. So again, with cables, you got to be careful about what your target supports and which cable you have. So the use cases with USB, really, it's got easy configuration. So early development is a great one. If you're just getting started, it's a good way to go. And if there's no other options available, use USB. So the benefits, it's fast, it's pretty easy. And I said convenient with a question mark here because you also need to have MDNS working correctly. And I'm getting into a drawback here, but on my computer with NixOS, getting MDNS configured correctly was actually kind of a bear. So if you're on a Mac, this is probably fine, but just keep that in mind when you choose to use a USB cable. Again, another drawback, it's wires. Got to avoid that rat's nest of cables. And it requires a data cable, not just power. So be extremely careful with this. If you've got that rat's nest of wires and you just reach for a USB cable, you don't know whether it's a data cable or not, you might be only supplying power, and it could be an hour before you realize that you don't have any data in that cable. So I've made this mistake enough to tell you, double, triple check that you've got a data cable before you use it. So moving on to Wi-Fi. There are a lot of ways to use Wi-Fi with Nerves. And VintageNet is an excellent package that makes it easy to get Wi-Fi up and running. It provides support for all the common and some uncommon Wi-Fi configurations. And although this device pictured here isn't exactly vintage, it really should be. That's a Linksys WRT54G. You've probably seen it before. It was released in 2002, and it's got a 125 megahertz Broadcom chip. It's got 16 megs of RAM and 4 megs of onboard memory. Probably don't want to use this wireless router. These routers might be more appropriate though. So use cases for Wi-Fi are pretty plentiful as well. They include hobby projects, prototyping, and commercial use. And before I move on, I want to mention that's an Asus RT AC5300. It's a pretty badass tri-band gigabit gaming router. And next to it, that's a Cisco AeroNet 155.2S. It's an outdoor access point that you might see if you're doing some commercial configurations. So with Wi-Fi, the benefits, of course, there's no wires. And it's pretty commonly available, although I wouldn't suggest getting your Nerves project set up at a coffee shop or anything like that. And I mentioned before, VintageNet is a great package for getting started. There's also an incredible sort of sub-package called VintageNet Wizard that allows you to set up an access point with no configuration and have that sort of, like if you're at a hotel or at a coffee shop and you log in through an active portal, well, it sets that up for you, and then you can configure your Wi-Fi. So if you want to save your network SSID and password from there without configuring it in your firmware, you can do that with VintageNet. And some of the drawbacks, well, even with VintageNet, wireless networking can present some confusing situations, like when you're dealing with firewalls or port forwarding, or if you've got intermittent connectivity or interference going on, it can be a little bit hairy. Before I move on, I want to mention this device here. That's a Hayes Smart Modem 1200. It was introduced in 1982 for $699, and it was the first practical all-in-one 1200-bit per second modem. And if my memory serves me, this is the first modem I used to get on the internet back in the 90s. So IEX, well, it's that REPL experience that's an essential part of working with Elixir. And with Nerves, you get IEX out of the box as soon as you SSH into your target device. You might see something like this when you log in for the first time. IEX has a lot of different use cases. You'll probably use it during active development on the host, and you'll use it when you're running tests. But you'll also use it for remote shell connections to targets, and there's a lot that you can do with it. I'd say you'll probably want to use IEX almost any time. I'm wondering if anybody recognizes this image. This is from Erlang the movie. This is when Robert Verding explains the symbolic trace of the number analyzer from their famous demo. So the benefits of using IEX are many. You get access logs, debugging, inspection, and you can even run code from IEX on the remote device. And it allows you to interact with the runtime environment. You can use ringlogger with common commands like ringlogger.next or ringlogger.attach to show the logs that have come in before you logged in, or tail the logs with attach. There's the RAM oops logger, which is a logger backend that records messages to a special memory region that survives reboots, which is really useful for capturing log messages that happen just before an unexpected reboot. And then there's toolshed, which provides essential tools for working with the command line like cd, dmessage, grep, ls, ping, and more. And with IEX, you can use a copy and paste method to copy in functions, values, even whole modules. And it's a pretty useful thing to keep you from needing to go through the firmware cycle of getting code onto the device with burning an SD card or sending it over the wire with Wi-Fi. Some of the drawbacks, though, are it's possible to break things when you're updating code in memory. And when you're doing this, it can really produce some confusing situations. So be careful with what you copy and paste into IEX. Up next, we're going to talk about my favorite. This is HotSwap. It's a magical package that enables fast and easy over-the-air updates to Nerves targets. And it does this by passing compiled modules to an IEX helper called NL, which leverages Erlang's RPC call to load new Beam code directly into memory. There's the link to the repo at the bottom there. I think this is really the galaxy brain move, in my opinion. So HotSwap has a number of use cases that include project development, library development, and hardware hacking. But if you're doing the type of hardware hacking like this image, I would say maybe don't. The benefits of HotSwap, again, there's no wires. You get a really tight feedback loop, and it's relatively easy to set up. You install it with the dep. There's a little bit of config. You get a EPMD node running. It sounds complicated, but the README explains it. It's not too bad. And you can combine this with OTP to iterate really quickly on supervision trees. Although drawbacks, if you're updating code in memory like this, it can present some confusing situations. And it's a pretty coarse-grained tool. It doesn't just send the module that you've changed. It sends all the modules in your project every time. And it doesn't really help if you're doing changes to your config. It's really just sending application modules up. And if you're changing the dependencies of your application, again, you're probably going to have to send all the firmware over the wire or reburn your SD card. So I mentioned OTP. OTP, of course, is that special blend of powerful abstractions that are rolled into a small set of battle-tested Erlang libraries. And this includes classics like supervisors, processes, links, and gen servers. The Erlang runtime system is made up of an emulator running on top of the host operating system. And the standard library includes this by default. So use cases for Nerves, at least, it's great for concurrent process management or tweaking startup sequences. And it's pretty nice when you're designing supervision trees, especially if you're using it in combination with something like hot swap, and you're able to restart your application, reload modules, and repeat really quickly. It's also great, of course, for debugging failure conditions. And before I move on, I dropped this image in here because it kind of made me think of OTP in the Beam. This is a US stamp that was released in 1995 of Rube Goldberg's inventions depicting his 1931 self-operating napkin. So some of the benefits of working with OTP are that you get direct control over process restarts, and it's an excellent developer experience if you use it in combination with IEX or hot swap for making in-memory updates. It's also got process inspection and communication, and you get fine-grained control over pretty much everything that's happening in your application. I wonder if anybody recognizes this image. This is an Ericsson AXD 301. It was their flagship telecom switch, and it apparently included 1 to 2 million lines of highly complex Erlang code and was capable of achieving the famous 9 nines of service availability. Oh, and if you were looking for drawbacks to OTP, sorry, better luck next time. So moving on to Livebook. And in case you haven't heard of Livebook, Livebook is an incredible library that allows you to manage live, interactive, and collaborative code notebooks. You can get started by downloading pre-built firmware releases, and those are linked here in the slide. And those firmware releases are going to include Livebook with a Nerves system image and a number of demo notebooks and packages that are going to allow you to explore different parts of hardware that might be common and used with Nerves. So you can find out more at livebook.dev. And the use cases for Livebook are when you're experimenting with new hardware, it's really nice to be able to just run the code right there on the machine or on the device and see what's happening in the browser. IEX is great, but putting it in a Livebook just makes it a little more approachable. It's also great for documentation and guides. If you want to do some work and save that for later, you can use Livebook. And of course, you could use that later for onboarding developers. Although I don't have any in this talk, I would like to see some talks in the future where it's used for demos. I think that that's a really exciting potential for Livebook. Speaking of books, that book there, that's an Apple PowerBook 3400C. And it was introduced back in 1997, and it was briefly the fastest laptop in the world with a PowerPC 603E processor. It was capable of running at speeds up to 240 megahertz. I still have this one in the closet. This was one of my early computers, and I loved it. It's a heavy machine, though. So with Livebook, the benefits include, of course, it's a live coding journal that runs on Nerves, which is still really exciting to say. It's collaborative, it's reproducible, and it gives you a really tight feedback loop for your Nerves workflows. And I listed here under the drawbacks some security considerations because those are listed in the README for the Livebook repo. And really, the considerations here are notebooks are not sandboxed. So really any code that you run in them can be run on the device, and that could be problematic. But In production mode, if you're running Livebook, a security token is required to access it, and you can password protect it. It's pretty safe in those regards, but you still have to be careful. Speaking of being careful, if you're rewriting your firmware and you haven't saved your notebooks that you've been creating on your device with Livebook, you might overwrite them. So be careful if you go and reburn that firmware image on your SD card. So moving forward, we're going to talk about NervesHub. If you haven't heard of NervesHub, it's self-described as an open source firmware updates server. But NervesHub is so much more. It includes a CLI tool, a certificate authority server, a device updates server, an API server, and a web front end. So it's got a lot of services and a lot of surface area that it covers. And there used to be a community-supported version of it that was running on nerveshub.com, but it's not there anymore. And if you want to install it, you can install it on AWS with the NervesHub Terraform repo that's linked here, although I would say it's not for the faint of heart. It's also possible, if you didn't want to use AWS and Terraform, that you can install each of those separate services listed above on their own platform, and good luck to you if you do that. So the use cases for NervesHub are, of course, commercial. If you've got a fleet of devices that you need to manage, NervesHub is an excellent way to do it. And if you're a consultancy that works with a business that does this, again, checkbox there, a very good idea. I've got a question mark here, though, next to community, because it's a lot more difficult to use NervesHub at the community level now. I'm hopeful that that might change sometime, but time will tell. So the benefits of using NervesHub, of course, you're going to get over-the-air updates that are coming from a cloud-hosted instance. And you can manage multiple products in NervesHub. So if you've got a data logger and some other device that it needs to talk to, you can manage both of those in tandem from NervesHub. And for each of those, you can have their own deployments of different versions of firmware. And in order to keep track of these, NervesHub so kindly included tags, which makes it easy to list out what you're doing or search from many products and deployments. I mentioned before, as a drawback, the community-hosted version of NervesHub is no longer available. And it is a little bit hard to configure the self-hosted version of NervesHub, but it's definitely possible. So if you're determined and you really want to use NervesHub, I think you can do it. I have. So we're reaching the end here, and I want to do a quick rewind recap. We've got NervesHub that we just talked about, which is great for cloud-managed over-the-air updates. And Livebook, which is going to give you real-time collaborative hardware hacking. OTP, which is very useful for managing processes, links, restarts, and doing things like introspection. We've got HotSwap, which is my favorite for fast, efficient, over-the-air module hot swaps. IEX for debugging, hardware hacking, and more. Wi-Fi, it's a widely available familiar transport protocol. It's pretty useful for sending your firmware over the air. The USB cable for getting started and convenient connections, especially good if you're new to Nerves. HDMI cables, which is great for easy viewing and console access. And serial cable, which is another really good one. I'd say it's the best debugging experience via direct console access if you're really just trying to get connected to your Nerves target and get moving quickly. And of course, there's the SD card, which is the primitive on which all firmware work with Nerves begins. So with that, you've been great. Here's a Roland 808. Thanks for coming to my talk. We've got plenty of time for more questions.
Jason, I got one comment to add about NervesHub first, and this might help everyone, because you mentioned some friction for the community solution, so I'll say, and yeah, like self-hosting NervesHub can be not for the faint of heart if you're starting out or you're running a hobby project or something like that. So one of the workarounds you can do in that case is when you build a Nerves project, it generates a firmware bundle and it comes out as a .fw file. You can take that and drop that into a GitHub release and be able to basically download those releases, that firmware file from GitHub. And that's kind of leveraging GitHub then for your firmware hosting and to be able to get that onto your devices. So I'd say for anyone who needs to go that route, you might want to check that option out first, and that might be the easiest way to do that.
Cool. Brian, it sounds like you had something to say, but you're muted.
Whoops. I said that was awesome. Great talk. Appreciate that a lot.
Thanks. Yeah.
Yeah, great talk. Thank you.
Yeah, that to me, like coming to Nerves, you know, there've been changes like VintageNet and this and that, and it's always felt like a little bit murky. Like, you know, I have started down one road and it's like, you don't use gadget mode with a Raspberry Pi 3? What are you, crazy? You know, so I think I've always been looking for like a little, you know, kind of like an oversight, like where are things now? Like, or what do you do if you have to go back to an older project? But I mean, I'm thinking in terms of things like, you know, like the serial, using a serial cable. I haven't really done that much. So now I know I need to. But, you know, just it just seems like such a complicated thing where you have all these different, you know, ways you can do things and different cables and different, different options. Yeah, it would be kind of helpful to, I mean, this information is great. You know, just in general, I feel like there could be like more information, like, you know, a flow chart or something. Oh, Raspberry Pi 3, you know, go, you know, skip this, you know, this is the preferred method. It's Wi-Fi and, you know, this works, but we don't recommend it, that type of thing. So I don't know if I really had a question in there, a lot of rambling, but.
Well, yeah, I think that's kind of why I wanted to make this talk. And it seems like there's so many choices to make. And the docs are awesome, but being able to get like a quick overview of what's out there and how it might be useful, I think is kind of a good thing for the community. And I think I would like to put a little more into this talk and add some use cases that make it more tangible. So you can see like, okay, if I'm doing X, Y, or Z, I want to use this method, or, you know, so it's easier to determine if you're in a certain situation, how should you be working with Nerves?
Yeah, and I can say the Livebook, I think that example for getting started, it is incredibly easy now. So that's definitely one that I would push. If I was going to be teaching a class, I would start with Livebook because it's just burn your SD card, configure, you know, Wi-Fi if you need or whatever to get access, and then you're up and running.
I'd like to see like a demo of the hot swap stuff and how that works. And I guess workflow, how you might interact between doing that and an IEX session. Are they mutually exclusive, or can you go back and forth between them? You know, hot swap something up and then interact with it?
Yeah, so you definitely can. And the way that I use it in my workflow, so I use Emacs and I've got like a post save hook on my buffers that will allow me to, if I like press Option Control S, it'll do the hot swap instead of just a regular save. And then it sends the modules up. I still have my IEX session open in another buffer, and I can interact with the code that just reloaded in memory right away. And when I'm working on like I mentioned like a supervisor, and I need to, something weird is happening with the supervisor, and I need to be able to quickly debug it and like design the strategy. It's much easier to do it through that module reload and then just like a application restart than having to go through any other firmware shenanigans.
When you do hot swap, do you lose your IEX session state?
No. I mean, it's just it uses that RPC call and puts the theme files right into memory. Yeah.
So speaking of hot swap shenanigans, then how does the hot swap approach that you just spoke to, how does that compare to copy pasting the code and dumping it in IEX?
It's pretty similar. I mean, you get the benefit of the compiler running on your machine, and like the ergonomics there are usually a little bit nicer than just dumping a bunch of text into your terminal. But I guess in comparison, if you really just wanted to do a single module instead of the way that HotSwap does it, where it just like compiles all the modules of the application and ships them, it could be a little more efficient. But if you automate it with like a keyboard shortcut or something, the workflow is really seamless.
Yeah, like that's kind of one of the things that I'm wondering there. Like, what's the timing difference between it? I guess, say compile time is the same. Like, what is that delay from actually telling it to do the hot swap and it actually completing?
Like 5 seconds.
Okay.
It's not too bad. It's nice. It's like enough for you to switch buffers and make sure that it compiled and then see it on your device.
And so like on a Raspberry Pi, for example, then you're still beating the reboot time by probably like 20 seconds still in that case, it sounds like.
Yeah, I mean, of course, it depends on how much code you're working with, but it's not too bad because you're not shipping the dependencies, right? You're just doing those compiled modules.
Yeah, it'd be cool to include some timing examples for these because they do vary quite a bit.
Yeah. I'm gonna write this down.
Yeah, another thing that would be cool to, or might be nice to compare, or at least maybe mention, would be the doing development on the host, because that can have like an even faster cycle time. But you can't do that when you're like you can't actually interact with the hardware when you're doing that. But you can mock it out or something.
I should have mentioned that. You're right. And John had a great acronym for this. I can't remember it now though, so maybe it's not the best acronym, but it was really fun to think about. Like do it on the host otherwise or something. Does anyone remember?
Yeah. No, but it sounds cool.
So what do you mean by developing directly on the host? Are you able to actually compile the code directly on the host, or?
Yeah, I mean.
Yeah. Sorry, I'm thinking target. So you can't develop on the target.
Well, in Livebook, you kind of could.
Yeah, and with the SSH, if you have an IX session going, you can test stuff out there.
Yeah, I mean, the idea with development on your host, though, is you probably want to be writing tests and writing your tests that they're going to run on the host, and you should be writing your application into layers that split up nicely so that you've got like a hardware interaction layer and then your application code, and that's really the separation that you want to deal with, and then keep everything as much as you can running in the host, and just have that hardware interaction be the one thing that's needed for the target device.
Yeah. Is there a way to emulate the hardware on the host, or like any sort of toolkit or tooling for that?
especially for scenic. There are drivers for, if like I've got an Inky driver, and doing the Inky development is especially slow because you got to wait for the screen to flash and for finally to do its thing. Whereas if you use the host driver and it's just running OpenGL in a little X window, then it's much easier and faster.
So for a few pieces of hardware, there are like some mock versions. Like I have one that I've been working on for like Govey Bluetooth LED lights. And then I forget, somebody's in the Nerds Slack has been working on one was that for the PyJuice or was that his other project? But he's been working on something similar.
The Bright Pi? Is that what you're talking about?
Oh, maybe. That might be it.
Yeah, Philip was working on the PyJuice in a Livebook, but then I think switched over to some other thing. It's a work in progress.
Yeah, the other thing to mention there when it comes to like architecting your system around host development, because that can really speed up your iteration time, is you can stub out or mock out your physical devices. So if you have a keypad or buttons or stuff like that you need to press, or both Jason's mentioned the display case. If you have other like types of outputs as well, you can mock those inputs and outputs, and you can say maybe this output on the host now writes to a log instead of controlling whatever hardware it was going to control. And from the inputs, maybe you stub those out to command line commands you can call, or other ways you can trigger that. And then you could use methods like dependency injection is one way that I've done it before. You can use stuff like that to replace these kind of like virtual modules or virtual pieces of hardware for your host development, and then it swaps them out to the target dependencies when you go compile it for the target and load it onto there. So that's a pretty cool way to do that.
And then there's like this, Alex, maybe you know more about it, but like a null serial cable or something. You heard of that?
Null modem?
Maybe.
Is that what you're thinking?
Yeah.
That's kind of similar to what the
It's like a
GPIO
virtualized
emulator does. A null modem will loop the transmit pin back to the receive pin. So whatever you write out that port, you'll receive the same message. But you could, but if you're doing host development, so like that's a way to get around that in, like if you actually need to connect to the target itself, or like that's at the physical hardware level. At the software layer, like you could just mock that out.
Yeah, use mocks or whatever.
If you really want to like work with some types of devices that support like SPI or I2C or something like that, they do actually have USB devices that expose those protocols, or expose devices back on the host that you can use to interact over those protocols. So if you're spending most of your time interacting with a piece of hardware from like your Raspberry Pi or BeagleBone, and you would prefer to just access it directly on the host, there are little products like this that you can buy. Like this is SPI driver. This is like I2C driver. And they just expose devices on the host file system. I don't know if there's any way to access them in Nerves yet, but it would probably just be a fairly simple kind of like layer, like little driver layer on that. And if you got those interacting the same way with how you would interact with the devices on the target, you could use that as a way to do some development and then move it to the target and retry it there.
Does the I2C driver show up as a normal I2C device in Linux, or is it another protocol?
I'm not actually sure. I haven't used these. I bought them from a local meetup right before the pandemic hit. But in theory, they should expose a device on your file system in your dev on like Linux that you can then probably interact with to send signals in a similar way. Send and receive.
Thanks for that.
Do you have any links to those? Can you buy those online?
Yeah, I'll give a couple Amazon links in a minute. I have to go and dig them up.
Oh, okay, cool. Thank you.
Speaking of, this is a cable that has no no data. So
I love it.
instead of trashing it, I've decided to label it what I'm going to use it for, micro, whatever, I don't know.
Yeah.
But yeah, that bit me recently.
I have a data cable that's a different color. It's just got some advantages.
I have in my cart on Tindy, I have a couple of like USB cable testers that'll just tell you if they have, signal through them.
Oh, that's handy.
I can't remember who said it off the top of my head, but somebody in the Nerves community. I want to say Frank, but I don't want to quote that if I've actually got it wrong. But somebody said just like the best way to be safe is just throw away all of the ones that do power only and just replace them all with data cables, and you'll never have the problem again, and you'll never have to deal with it. It's just so much easier if you're doing hardware development on a regular basis.
I actually had this thought as well, like just this afternoon, which is like I really want like a piece of hardware that I can plug both ends of the USB into, and it'll tell me exactly what it's capable of. If it's got the bad resistor, like on some of those older USB-C cables, and what it's kind of rating from by attempting to do transfers and looking for signal loss or something. It'd be like really cool.
Now I really need to buy what's in my cart, which is those two things I just posted.
Anyone else have any other questions for Jason? No? Cool. All right. I'll go ahead and stop the recording. Thank you very much, Jason, for the presentation. This has been awesome.